Good morning, students. We're working on section 2.3, addition and subtraction with fractions. Let's go. So we're going to learn to add and subtract fractions with like denominators. We're going to learn to find the least common multiple, also known as the LCM, of two or more numbers. And we're going to add and subtract fractions with unlike denominators. So adding fractions with like denominators. The denominator is the bottom number in a fraction. And if the bottom numbers or denominators are the same, then you just add the top numbers, as you can see that's demonstrated here. We have A over B and C over B. So they both have the same bottom number or denominator. So we put it on the bottom. And then we just add the top, A plus C. And that is where B is not 0 once again. So here I have it, and I look at it, I go, well, they have the same denominator, so I just need to add the top. So 3 plus 4 is 7. So my answer is 7/8. Now, I do need to ask, can I reduce? When you're adding or subtracting, don't pre-reduce, okay? You have to reduce after, but when multiplying and dividing, you do want to pre-reduce. Here's the next one. Look, my denominators are both 8x, so I have the same denominator. They just happen to have a variable this time, and that's okay. So I'm going to add those together. 3 plus 4 is 7. 7 over 8x. And here my denominators are 15, so I can add them all together. 2 plus 3 plus 1 plus 6 is going to give me 12 over 15. Now, 12 over 15, I'm going to start to think about that. Do they have a common factor in them? And they do. 3 goes into both of those. 3 times 4 and 3 times 5. So we're going to cancel out the 3's, making them 1's. And what we're left with is 1 times 4 on the top and 1 times 5 on the bottom, which is just 4 over 5. So reduce when possible. You will always lose points on an assignment or on an assignment or on a test or quiz if you do not reduce fractions. And our last one on this page is 5 is our common denominator. So we're going to add the top. But if I look at the top, they're not like terms, are they? So the best I could do is just leave it just like that, showing a common denominator, but the top terms cannot combine because they are not like terms. So now, what happens though when they're not like denominators or the same denominator? Well, that's why we have to learn to find the LCM. So first way to find the LCM is to find the prime factorization of each number. List the prime factors that appear in any one of the prime factorizations, and then you find the product of these primes using each prime the greatest number of times it appears in any one of the prime factorizations. And you go, whoa, what does that mean? I'm going to try to demonstrate what that means. Let's try to read it again. So you can study that out, but we're going to try to look at it. First of all, let's talk about what is it to be a multiple. So if I had the numbers, and let's not look at those numbers yet, but let's just say if I had the numbers 6 and 12 and 3. And I asked, what's the greatest multiple? Well, multiples means I'm counting by that number. So multiples of 6 are 6, 12, 18, 24, 30, 36, right? And 12 is 12, 24, 36, 48, and 3 is 3, 6, 9, 12, 15, 18, and I'm looking for the lowest common, one that they all have in common, and it's the smallest one. And look at that. It happens to be 12. That is the lowest common denominator of those. And so that's what I'm going to be looking for is the least common denominator. Let's try another set of numbers just to get one more try at it. Let's try 3, 7, 4, let's see, 14, and 2. That's going to be a tough one. So 3, 6, 9, 12, 15, 18, 20, 21. Let's see if that's good enough. 7, 14, 21, 28, 35, 42. Okay. How about 14? 14 gives us 28. And what, 32? No, 42 is the next one. 42, and add 14 to that again. We get 56, add 14 to that again, and we get 70. And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm looking, I've got 14, 14, 14, but no 14 here. So I haven't found one yet. Let's see, I'm like 18, no 18 there. I got a 42 here and a 42 here. Eventually the twos, because if I multiply 21 by 2, that gives me 42. So down the road here, there's a 42. And down the road here, 24, 27, 30, 33, I will come up with a 42. And that will be the first time that all four of these numbers have something in common. So that would be the least common multiple. But boy, this sure takes a long time to do it this way. So we're going to learn how to find that using prime factorization. So here are some numbers that we're going to work with here now. We've got 27, 15, and 16. So we're going to take the prime factors of each one of those. 27 happens to be 9 times 3, or 3 times 3 times 3, or 3 to the third. So 3 times. 15 is 3 times 5, and 16 is 10 times 6, or 2 times 5 times 2 times 3, which is 2 squared times 3 times 5. How do I now find the least common multiple from that? Well, it's like a play. Take every character who appears in the play. So 3's appear, 5's appear, and 2's appear. So I'll start with 2, 3, and then 5. But that's not enough. I have to ask, what is the greatest amount of times that a 2 appears? Well, 2 appears squared here, and 3 appears third here, and the greatest for 5 is just 1, so we can leave that 5. So that's really 4 times 27 times 5. So we're looking at, we have to name all of the principal players, and then we have to put their highest power on them, okay? So you name the principal number factors, and then you have to put their highest powers. And that's what it meant in that paragraph before, right here. Find the product of these primes using each prime and the greatest number of times it appears. So in that last one, 3 appeared 3 times. So that's why we used the 3 to the third. 2 appeared at its greatest power to the second. That's why we use that. And 5's greatest power was just to the first. So if we're looking for the least common multiple, it's 540. So why are we trying to find common multiples? Well, let's do it here too. But oh wait, Mrs. Stubbs, I got a variable. That's okay. A variable is a factor. And so we're going to show you how to prime factor that. First, prime factor the two on that 4, or the 4, sorry. And it's 2 squared. And then the other factor would be x, okay? X to the first in this case. So the next one, x squared y, well, it's x squared times y. Look at the greatest power on the x's is now 2. And the next one, 6x squared is really 2 times 3 times x squared. So if I'm looking at the characters, there's a 2, there's an x, oops, I'm going to erase that. There's a 3 also, there's an x, and there's a y. Now let's look for greatest powers. Well, on the 2's, greatest power is 2. On the 3's, it's just a 1. On the x's, the greatest power is a 2, and on the y, it's just 1. And so I would leave it like so. And then I would multiply that out. 2 squared is 4, 4 times 3 is 12, x squared y. So adding fractions with unlined denominators. We now are, to do that, we have to find the least common multiple of the denominators, okay? The bottom number. This is called the least common denominator. So LCD might be something else we say define. Change each fraction to an equivalent fraction. Remember, we practiced that, finding equivalent fractions with the LCM as the denominator. And then we're going to add the new fractions because our denominators will be the same, our numerators will be different, and then reduce if possible. So let's practice a few. Okay, so here I have 4, 8, and 10. So I'm going to prime factor those common denominators, or I'm going to find one. 4 is 2 squared. 8 is 2 to the third, and 10 is 2 to the 5. So who are my principal players? 2's and 5's, right? And what's the highest power on the 2's? It's to the third. So that is my prime factorization because the 5 is the 1. So if I multiply that out, that's really 8 times 5, or 40. So I know my highest power, or my LCD, or my least common multiple, is 40. So I'm going to have some kind of problem here over 40, aren't I? But remember when I'm making 1/4 to be equal to something but over 40. Well, what did I times the 4 by to get 40? I times it by 10, didn't I? So if I times the top by, or the bottom by 10, I have to times the top by 10. So I get actually 10 over 40. And you're going to see how that's going to make an effect up here. And if I were doing the 8, how did I make 8 be equal to a 40 on the bottom? Well, I times it by 5, right? And my top was a 3, so 5 times 3 is 15. And finally, how did I make a 10 become a 40? Well, I times it by a 4, so I need to times the top by 4, and it was a 3 up there, so I get 12. So watch what will happen. I should have, then, for 1/4, there was a 10 over 40, plus a 15 over 40, plus a 12 over 40. Now they all have the same common denominator, don't they? And I just add the top terms. So let's go ahead and finish that through. Notice that they've just multiplied it to get it. Now they combine them all, and finally they end up with 37. 10 plus 15 plus 12. My denominators are now the same because I made equivalent fractions, higher equivalent fractions, okay? So that they would all have the same denominator. And that's going to be our focus every time we're adding or subtracting fractions, is to make sure the denominator is the same. If the denominator is not the same, we have to make them equivalent fractions by writing them as a higher fraction. So 21a and 28a. So first of all, prime factor 21. That is 3 times 7 times a. And prime factor 28, that's 2 times 7 times a, or 2 squared. So who are the players? Well, the players are 2s, 3s, 7s, and a's. They're going to all times each other. But I got to have the right power. Okay? This is an a, not an 8. A, all right. 2, what should its power be? It should be squared, right? What about 3? Its highest power is just a 1. 7's highest power is just a 1. 8's A's highest power is just a 1. So I really have 4 times 3 times 7 times A when I do this to make my denominator. So erase my scribbly there. That's what they find out. And they happen to find out that it's 84A. Okay? So in each fraction, they're going to have to, we've got 84A as our common denominator. So we have 84A. How do I make 21 become an 84? Or 21 as 84A? Well, I'm going to have to multiply it by 4 times A. And if I do the bottom by that, I have to do the top by that, don't I? And so that would give me 20A on the top. And how do I make a 28A be an 84? Or 20, yeah. Sorry, there was already the A there. So I didn't need to times it by an A. Sorry. Let's re-erase that and go back through that. So erase your mind really quick from what I just did so we can look at it correctly. I had 21A and I wanted it to be a 48 or 84A. What do I need to times by? Well, I've already got the A. I just need to times by 4, top and bottom. So that would have given me 20 over 84A. That's an equivalent fraction to 5 over 21A. And then if I wanted to do 28A becomes an 84, I'm going to times that by 3, top and bottom. And that gives me 15 over 84A. Sorry. And that's how I got that. So let's watch and see what they do really quick. Times the 21A by 4 over 4, and the 5 over 20A by 3 over 3. We now have equivalent fractions. I can now just add the top. 20 plus 15 is 35. 80 over 84. I think, is there anything that they have in common? There is, I think. 35 is 5 times 7. 84 is 7 times 12. So look what will cancel out. The 7s. Wow. And I'm left with 5 over 12A. And that's my final answer. Let's do another one. Here we have 6 and 4. Now, maybe we don't need to do that. Maybe we know really quick that they both go into 12. And so you're like, I know they both go into 12. I don't need to do all that. And if I times 6 by 2, then I'm going to get up top, I'm going to get 8a, because 6 times 2 is 12. And if I times the 4 by 3, 4 times 3 is 12, and 3 times 5 is 15. And that's what I get. So that works, right? And I could leave it like that. I'll show you how they did it. They find that it's 12. And we can't combine these two because they are not like terms, not like terms. So we leave it as it is. Okay, subtraction is done the same way. You have to have a common denominator, okay? And then you just proceed as in subtraction like we were doing with our integers. So here I have a common denominator. It's 8a. So I rewrite that as 1 minus 5 over 8a. Well, 1 minus 5 is a negative 4. Now, if I can reduce, I do. Well, 4 goes into a negative 4 a negative 1 times, and 4 goes into 8 2 times. So I can cancel out those 4s, leaves me that negative 1 over 2, and I get negative 1 over 2a is my final answer. And I can write it like this, remember? Or I can write it like this, and I can even write it as this, but we stay away from that, okay, if we can. All right, 45 and 72, I'm never going to be able to find that, except if I do my prime factorizations. 45 happens to be 5 times 9, right? And 9 happens to be 3 times 3. So 45 is 3 squared times 5. 72 is 2 times 36. 36 is 2 times, or 6 times 6. And that's just 2 times 3 and 2 times 3. So if I look at my prime factorization, it's how many 2's do I have? 1, 2, 3, 2 to the third. And how many 3's do I have? 1, 2, 3 to the second. So now I'm ready to find it. My characters are 2's and 3's and 5's. My 2's, the highest power is 3. My 3, the highest power is 2. And then 1, and so I really have 8 times 9 times 5. And that ends up to be what? 40 times 9, 360. So they're going to show us how they do it. They prime factored it. Yep, and it's 360. So now I need to rewrite 1 over 45 as a higher fraction with a denominator of 360. Well, what do I need to times 45 by to get 360? Well, 8. So if I times the top and the bottom by 8, I should get that. And 72, I need to times it by 5. And so when I go ahead and do the math, I get 8 over 360 minus 5 over 360 is 3 over 360, but 3 goes into both those numbers. 3 goes into 3 once, 3 goes into 360 120 times. And there is my final answer, 1 over 120. Okay, here I have a variable and a 5. So they're both prime, aren't they? So I need x's and I need 5's. And the power on those would just be themselves. So my common denominator here is going to be 5x. But I have to rewrite this 3 over x so that it has a denominator of 5 over x. So what do I need to times it by? 5 on top and bottom, right? So I'd really have 15 over 5x. And if I were doing 2/5, how do I make that a 5x? Well, I need to times it by x, don't I? So if I times an x here, times an x here, that actually leaves me 2x over 5x. And then I can combine those, 15x, or 15 over 5x plus 2x over 5x is equal to 15 plus 2x over 5x. And we know that these cannot be combined. They're not like terms. So this is our final answer. And just have it done neatly for us. Oh, well, we were subtracting. Oh, we can't do that. So there we go. So here you have some 6 problems that you're going to practice. Take a moment to see if you can do them and then check them out. Okay, so let's look at these. Number one, I have a negative 5 times 3 over 10. Well, when multiplying, we just times top, bottom times bottom, right? So that's really just a negative. Oh, and I'm going to pre-reduce. So now I have a negative 1 times 3, which is a negative 3 over 1 times 2, which is 2. Why did I do this right here? Why did I go ahead and just make it a fraction like that? Well, any whole number, you can write it as a fraction by putting 1 underneath it. So that's just to help me know I'm dealing with fractions, okay? All right, over here, I'm dividing, so I need to rewrite, flip to multiply, and write the inverse. And that happens to give me 9 over 16, and those do not reduce. Over here, I've got multiply, multiply, and then I'm going to subtract. So let's see if I can do some reducing. 4 and 20 make 5. So 4 or 1, this is now a 1. 1 times 3 is 3. 5 times 5 is 25. So I have 3 over 25 minus 1 over 2. Now, I need a common denominator, don't I? Now, I can do a prime factor, but I'm pretty quick at this. I've been doing it for a while. I actually know that 50, oops, go back. I actually know that 50 is the common denominator for this. And to have made a 25 of 50, I had to times that by 2. So I'm going to times the top by 2. So that's going to give me 6 minus, and to make a 2 of 50, I have to times it by 25. So I'm going to minus 25. And that's going to give me a negative 19 over 50. Okay. Number 4, my denominators are the same. That's awesome. So I'm just going to add the top. 1 plus 1 is 2. So I have 2 over 2a. But I can reduce now. The 2's will cancel out, leaving me, this becomes a 1 up here, a 1 over a. Oh, I do not have a common denominator here, but I do know that it's going to be 5 times x, because that's what that would be, wouldn't it? So to make the 4 over x make this be a 5x, I have to times this by 5, so I times the top by 5. So that's going to give me 20 minus, now to make this work, I have to put an x on it, so I'm going to times by x, times by x. So I'm going to minus 3x, and there I have it right here. I can't do anything further. They're not like terms. They won't combine down. So 24 and 36. Prime factorization of 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. So that's 1, 2, 3, 2 3s, and a 3. That's what 24 equals. 36 happens to be 6 times 6, or 2 times 3 times 2 times 3, which is 2 squared times 3 squared. So my players are 2s and 3s, and their highest powers is a 30 here and a square here. So 8 times 9, which happens to be 72. So 72 is my denominator. 24 goes into 72 3 times. 3 times 5 is 15. That makes that equivalent fraction. And 36, 72, I had to times it by 2. So that gives me 14. I times this by 3. So 15 plus 14 is 29 over 72. So let's just check and see if we got those. Negative 3 halves, negative 1950, 2 or 9 sixteenths, 20 minus 3, 1 over a, and 29 over 72. So we did get them correctly. There they've been done. And hopefully you get this all, that it works well for you. We are going to move on. Our next video will be 2.4. So hope to see you then. Have a good day.